All right, everybody, we are now back to talk about DHCP, which is Dynamic Host Configuration Protocol. Of course, we already talked about CDP and LLDP, which is going to help you identify what port the device that you're interested in looking at is on, and that's going to also give you the type of device that's on that port. We talked about VLANs. We also talked about access ports and trunk ports. Of course, when you assign a VLAN to a port, like an access port, you're defining a different switch on the physical switch, essentially. So you're saying that if a port is in VLAN 11, you can only talk to other devices on VLAN 11 unless that trunk port is set up for you to talk between VLANs or route between VLANs. And we talked about how to do that. Now, that infrastructure foundation has kind of been laid for us, so we can now talk about DHCP, which is going to be address assignment, so IP address assignment. Of course, we can assign the addresses manually if we really want to, but who really wants to do that? We don't have to do that. We can use a method to assign addresses to devices if we want to. So in the blueprint, there are a couple different methods that we can use. The number one, which is not so fun to use, is the CUCM method. So we can use CUCM to assign IP addresses. It's not so fun because it's something that you can't really verify. You can't see whether CUCM dished out an IP address or not. The other method is iOS, and you can use iOS to issue out IP addresses and different options within those DHCP scopes. So let's talk about the first one, and let me pop over to the slides here real quick. So we'll talk about CUCM DHCP server. First of all, we have to face the music here and face the facts. It's a flaky thing. I mean, I don't know really anybody that uses this in production in the real world, but we have to use it in the lab because it's on the blueprint. So let's get pretty familiar with how to use it. First rule of thumb, make sure that you shut down the DHCP monitor service before you configure the CUCM DHCP server. Now, the DHCP monitor service is going to be the service that actually controls the server. So if that service is not running, you won't be able to dish out any IP addresses in DHCP because it won't be working at all. So it seems counterintuitive then to actually shut the service down before you configure it. But I can tell you from experience that if you ever configure DHCP server on CUCM and make a mistake or have to go back, or maybe you just edit something or change something throughout the lab later, whatever, it's probably not going to work correctly. In my experience, I've always had problems with the DHCP server coming up correctly. It may not dish out an IP address. It may dish out an IP address on the wrong subnet. It may not give you a default gateway. It may do crazy things. So the best policy is to shut that service down before you configure anything. Of course, we're going to bring it back up so we can actually use the service, but we have to shut it down first before we do anything. So let's shut it down, the DHCP monitor service within Call Manager Serviceability. So let me actually show you where to do that real quick. So if I pull up a CUCM here, and this is the Site B cluster, if I do the navigation, unified serviceability, and hit go, I can then go, when it loads, to the tools and service activation section, and you see the Cisco DHCP monitor service. We can uncheck that box and hit save. And once we do that and it comes back, we're good to go ahead and start configuring the DHCP server. So I just wanted to make sure I emphasize that point very clearly because it can make you lose a lot of time if you don't do that correctly. So make sure that service is shut down, and then from there we're going to actually configure our scope. So, and I'll show you how to do that here in a minute, but let's go back to the slides for now. So it is configured under the System, DHCP, and DHCP Server and Subnet menu, and you can configure it within the Subnet menu, or I'm sorry, the Server menu almost completely. You can do a lot of configuration elements there, except when you get down to the specific network that you want to create, maybe you want to have specific settings that override whatever's in the server section. And we'll look at that as well. You don't really have to configure anything under server either. You can just say that, guess what, my DHCP server is going to be running on this device. That's it. And then you can go ahead and configure your IP addresses and scopes and things like that that correspond to that server that you just created. So the whole purpose, once again, is to dish out an IP address to a device. So we need to make sure that we do that somehow. Subnet contains information such as default gateway and TFTP. Obviously, these are the two most important things for phones. I mean, you have to have a default gateway for any device that's going to be connected, or else they're not going to know how to even get out of their own local area network. So that has to be in there in the DHCP scope somewhere. Also, you have to have a TFTP server for your phones to know where to get the configuration file from. And notice there is a difference here as well. I didn't say register with that server. I said get the configuration file from that server. So we're not talking about phone registration here. We're talking about phone configuration. So we're giving it an IP address by which the phone can actually go to and download its configuration. So once again, stop DHCP services before configuring. You'll thank me later is what I've officially put here in the slides. So once the actual configuration is done, of course, you can pop that DHCP server back on and it should start dishing out addresses for you, provided that it was configured correctly. So let's take a quick look at that. And that would be under the System and DHCP menu, under DHCP Server. And we only have one server here on Site B, which is going to be this 23.11 address, 10.10.23.11. And notice here I have absolutely nothing configured in this DHCP server configuration. I do have the ability, however, to do a DNS address here, also primary TFTP server and secondary TFTP server. Also can give it a domain name, TFTP option 66 if I want to. Also I can set some different timeout values for when the IP address is leased, when the device that the address was leased to should renew that address, things like that. I mean, and some of these settings you'll see actually repeated in the subnet configuration. So that's why you don't have anything necessarily configured in the server menu itself. You can configure the server and saying, guess what, it's running on this server and that's it. So now if I go down to System, DHCP subnet, and click Find, now I can see that I have two DHCP scopes. Of course, they're both running on the same DHCP server, 23.11, but I have two different scopes here. And let's click on one of them, and just to see what you would do to configure this thing here. I've got a subnet address, which is 10.10.21.0. So the .0 address would be the actual subnet. It's not a host. It's going to be your actual subnet address. So if this is a different subnetwork, you might have an actual integer value here other than 0. But we do have the subnet mask set as a /24, so 0 makes sense here. The primary start IPv4 address here, we're saying that when an address is issued, we want to start with the address that's listed here. So we're going to say, I want an address to start with 61 here. And the end IPv4 address, I'm saying you can assign an address that starts with 75. So between those two ranges is all that this DHCP server is allowed to assign to clients. That means anything outside of that range maybe is a manual configuration or just something that we don't want to assign to DHCP. So very limited range of addresses here that we're using, but maybe this was a requirement of a lab or something like that. Maybe it said assign addresses only in this range, and so this is how you would do that. The primary router IPv4 address here, we've got 10.10.21.1. Of course, that's going to be the default gateway that these clients are going to use to get out of their network. So the client gets an IP address here from the CUCM DHCP server. It says my default gateway is now 21.1, so I need to talk to that default gateway if I want to get anywhere in the network. So scrolling through, of course, our subnet mask is configured there. And we've got a primary TFTP server configured here as well, which means that any device that has got an IP address from this subnet or from this DHCP scope is going to use 23.11 as its TFTP server, which means it's going to try to get its configuration from the TFTP server in some fashion. So that's all it's telling it to do there. And I really don't have any other settings here like ARP cache timeout or IP address lease time. I could, however, set those up if I wanted to say, make sure that your IP address lease is no longer than 10 hours or something like that. So this time is in seconds, so you'd have to go, 10 times 60 times 60 to get that information because the minute's in seconds. So, and then of course you hit save, and if that's all the configuration you're doing, go back to serviceability and start your DHCP service back up. And that way you can start dishing out addresses. So, moving back to the slides here, if I can. The next thing would be the iOS DHCP server, and this is a lot less flaky than the CUCM server. It still has its little quirks here and there, but most of the time you're not going to have too many problems with it. So the iOS DHCP server, would be a very popular option for that anyway, would be the excluded address option. So when you have an excluded address from your DHCP server, you're saying it cannot be in that range. So whereas in CUCM we said we're defining the specific range that the IP addresses can be or can use, with iOS we're defining the IP addresses that they can't be. So it's just a different way of assigning them, of course. So we can do that by defining a DHCP scope or pool on the router itself. And let me just show you how we do that, of course. So let's go to the command line, and I don't remember if I have one configured here or not. I don't. Let's see if it's over here. Okay, I do have one here. So I just did a show run section DHCP to see these configuration commands, by the way. So the command, first of all, I have in here, IP DHCP excluded address 10.10.11.1 and then 10.10.11.50. So that means in this range between 1 and 50, we're not allowed to assign any addresses. We're excluding that range from DHCP assignment. And then we also have another statement here saying we're excluding 66 all the way up to 254. So that means then we're allowing IP addresses in the range 51 to 65 in this case. So we're allowing those two IP address ranges to exist there and for DHCP assignment. So a good little gotcha here is you want to make sure that you put these configuration commands in first. Because if you configure your DHCP pool before you configure these commands, then it's possible that one of your devices could get an IP address that it's not supposed to have. And as you well know, if you've been working on CCI voice or with phones for a long time, these phones can be a little bit sticky with IP addresses. They tend to hold on to them a little bit. So sometimes it can be challenging to get them to get a different address. So make sure that you put your excluded address command first when you're configuring a DHCP pool. So we've got that there. Now the DHCP pool itself here, we've got IP DHCP pool HQ. We just named it here, whatever we wanted. We're giving it a network, which is 10.10.11.0, and it's a /24. We gave it its default router, and we've also given it an option 150. So we also have other options we can do under there as well. If I show you real quick, IP DHCP pool HQ, you can do a question mark and see all the different options that we have. Quite a few options. So this is a very basic configuration then that I have here. I'm basically telling it, hey, there's your default router, and that's where you're going to get your configuration from. And oh, by the way, your IP address has to be in this range here in order to be part of this DHCP scope. So that's what iOS DHCP looks like. Now, that, of course, is going to be dependent on where the device is located. And this gets me into something that I want to diagram, actually. So let me get rid of this other diagram that we had here. And let's talk about how the DHCP service actually happens. So let's say that this is our client device here. And we'll label it as a phone. And then that is going to be connected to a, let's just say router. We'll skip the switch here. It's connected to a switch, of course, somewhere. But then it's trunked up to a router maybe, or maybe this is an ether switch module in the router. Doesn't matter. It's connected to a router on the local area network. So this is, let me just change colors here. This is a broadcast domain. Okay, so if I send out a broadcast, that means that everybody on this local area network is going to see that broadcast. So if I connect, from here to the router, I can successfully broadcast to that router. So how DHCP works, of course, I'm leading up to this, is that it is a broadcast. So you're going to send a DHCP discover out, DHCP discover, and that's going to be sent out from the phone to the router, or the client to the router. And then the router is going to send back a DHCP offer. So it's going to offer that address to the client. So it's, the DHCP discover, by the way, and I kind of skipped over this, is a broadcast. The whole reason why we have to be in the same broadcast domain. It's a broadcast message that goes out and says, hey, is there any DHCP servers anywhere? And then the DHCP server will respond and say, as a matter of fact, there are, and here's an IP address that you can have. So DHCP offer comes back there. And so then from the client side, once it receives the offer, it has to officially request that address here. Make sure I'm not running out of room. It has to officially request that IP address that it was assigned from the DHCP server. And then finally we have, from the DHCP server coming back, we have an acknowledgement. So we're acknowledging that request was made, and we're saying you're completely fine to have that address. So with this said, we have to have our clients on the same broadcast domain as the DHCP server. Now, for those of you that worked with this in production environments, you know that this is not always possible to have all your clients on the same broadcast domain. It's not really even good design either. So in small networks like this, perfectly acceptable to have your client on the same broadcast domain as your DHCP server. In this case, it's just a router that's assigning the addresses. So this is completely fine. Now, if we had a situation where the DHCP server was located elsewhere, let's say that, make sure I'm not running out of room up there. Let's say that we had a CUCM device up here, and that was actually going to be providing DHCP services. So now the client has to somehow make a DHCP request to the router. And of course, we can't just go to every single client and say, all right, so your DHCP server is going to be here. We've got to make sure that you're going directly to the CUCM server. You can't really do that. That would just be ridiculous to configure. Now, the best way to do this, and really the only way to do this, is to say that when you get a DHCP discover message coming in, or a broadcast message coming into that local area network, that if you don't want that local device to be responsible for that DHCP request, then you can say, I'm going to forward that request onto a different device. And that's where the IP helper address command comes in. So if on this port here, we have IP helper, address, we say IP helper address, and we give it an IP address of the CUCM server. Let's say that this is 23.11 like we had. We can say 10.10.23.11. And so any DHCP discover message that comes in from that client is going to point directly to 10.10.23.11. And 10.10.23.11 will then respond to that DHCP request. So it knows that it can't, broadcast it back, but it's going to offer it back to the router itself, whatever interface it came from on the router. So the router then will forward it back onto the client. And then so that's how that process is going to work. And that's a very important command to know here in the, let me just get out of the way real quick. So the IP helper address command, we see x.x.x.x, is necessary if the DHCP server is on a different LAN. So this is all the diagram was referring to there. Is of course if it's on a different it's on a different place somewhere, then you have to make sure that that helper address command is in there. So this CUCM server then is going to be the DHCP server for this client, provided that it has the the IP address that is in that subnet of this interface here. All right, so let's go to the slides here and go through a little bit more. This is an example, once again, of the DHCP server itself. Kind of skip quickly through this because I already kind of demoed that out. And this, once again, is an example of an iOS DHCP server. So we've got our excluded addresses in there. We've got our DHCP pool and so forth. And that really is all there's going to be to the DHCP configuration. Once again, we've got our CUCM DHCP server. We've got our iOS DHCP server. And those are going to be handling the address assignment responsibilities for devices in a specific VLAN. And those could be obviously local to that subnet, and which means that you don't need the helper address, or they could be a different device somewhere else, which means that you would need the helper address to make sure that happens correctly. So once again, that's DHCP. We're now going to talk about NTP in our infrastructure services section, and we will move on to that one next. Thanks again.